Okay, I've reduced the voltage to 7.4 volts to mimic a 2-cell lithium ion battery, and I found that the noise appears to be mostly gone. There is still some kind of ripple, but it's not a problem. See, that's the ground side of where the capacitors used to be. So that's the ground side of the power, the main power. And there's no major spikes, just these little ripples here. Now, if I connect it to the gate of the MOSFET, you'll see that there's a lot of ringing, but the frequency seems to have changed. There we go. There's a lot of ringing, and the oscilloscope is having trouble. It's supposed to be triggering on the falling edge, not the rising edge, but it's triggering in the same place every time, so at least you can see what's going on to some degree. And it's got a lot of ringing, but at least the frequency is different. You see the divisions per second is 0.1 microsecond, same as before, but there isn't this. Wait a second, no. It was 0.5 microseconds before. Just a second, I'm going to change it. Let's see if we can change this. So the oscilloscope is a little bit difficult to use. Okay. Let's make it 5. Maybe let's make it. Oh, let's just make it the same as it was. Okay, just to be sure. See if I can get the sewing needle on the thing. There we go. Okay, so look, the frequency of the square wave is completely different. The time division is. Oh, wait a second. There we go. See, it's a glitch. It's for short periods we get a very high frequency square rectangular wave signal. For short periods, which is not at all clear why. Am I maybe touching the wrong piece somehow? Oh, that might be what's happening. No. Well, there's nothing close to the gate pin that I could accidentally be touching. It would have to be like I don't know what that high frequency is. But there's nothing close to the gate that I could accidentally be touching instead. Is there? No. That's the center of the H bridge, so it's going up and down the way it's supposed to. Approximately. Okay, so let's measure the PWM frequency. See if I can anyway. It's supposed to be approximately 50,000 hertz, so if I set it to 10 microseconds, 20 microseconds, then I should be able to see. Yeah, a nice square wave signal, exactly the way it's supposed to be. So everything's working nicely at 7.4 volts, except that I'm not sure if the 4-tier driver is actually working right. I know Deku said that it takes 10 volts to do that. Oh, wait a second. We've got a bunch of interrupts being triggered here. That's now, today. That was a couple minutes ago. It says 10:30, and it's now 10:36. So maybe when it was being turned on or something. Let's turn it off and turn it back on again. Takes a little while for the power supply to drain. Okay, here we go. It turned off. Turn it back on again. So now I check to see if it's working by pressing T, and it reports the radians per second. So it seems to be working, and we're not getting any major indication of what's going on. Is the fan turning? Yeah, the fan's turning. See, the fan's turning. So what happens is when it gets a ton of interrupts, it gets so many interrupts that it stops turning because it can't do anything else. So, okay, that's my investigation. I don't want to overload you.